So here we are. I'm just going to take you through the mechanics practice papers. So it'll be in two clips, question 6 and 7, then a second one, 7 and 8 and 9. Again, this isn't really teaching. This is just so you have got a copy or somebody talking through the answers like I would have done in class. So a boat travels from A to B, then from B to C. The displacement from A to B is minus 28I plus 80J, and displacement from B to C is 130I plus 15J. And we come down to the question. Find the total distance travelled in moving from A to C. So we need the distance A to B plus the distance from B to C. So the key word to pick up in the question is that it's distance that we're working on, not displacement. So the magnitude of the distance from A to B is equal to negative 28 squared plus 80 squared square rooted using Pythagoras. So that comes out to be around 85-ish, 84.75. We also need the distance from B to C. So the modulus sign is showing it's the magnitude, and that's going to be the square root of 130 squared plus 15 squared. So that is equal to, tapping it in a calculator, 130.86. So the total distance is those added together, rounded off sensibly, and we get that around 216. Let's check the units, meters. That's part A done. Part B then is find the angle AC makes with the unit vector I. So the vector AC is equal to the vector from A to B plus the vector from B to C. So AB we can take down as minus 2880. I much prefer to work with the column vectors than with the I's and J's. Yeah, 130, particularly writing on the iPad, my writing seems to be even worse than usual. So we get minus 28 plus 130 is 102, and 80 plus 15 is 95. So we can now sketch that. That's the I direction. So we've got 102, 102 and 95. So angle we want with the positive I, theta, tan theta equals 95, the opposite over the adjacent 102. So theta equals arc tan of 95 over 102. Tap it in the calculator, and that comes out to be 42.96 degrees. Go back, read the question, find the angle the vector AC makes with the unit vector I. So I would say theta equals 43 degrees anti-clockwise from positive I. Just to finish off. Okay, now hopefully down here I've then got question 7 ready. Yes, here we go. So, question 7. Again, reading through the question, picking out the key facts. A car starts from rest to point A, constant acceleration of 11 meters per second squared for 8 seconds. It's then maintained after 8 seconds. It's maintained for t seconds. It then decelerates from this to 40 meters per second in a further 2 seconds, reaching the point B. And we need a velocity time graph. So, what have we got? Starts from rest, so this is the velocity, this is the time. Accelerates for 11 meters per second for 8 seconds. So that's a Suvac constant, U equals 0, A equals 11, T equals 8, and we want V. So V equals U plus AT, so that's 0 plus 11 lots of 8, which is 88 meters per second. So we've got an acceleration up to the 88. Yeah, so there's 88 and 8. And then we've got constant speed, so that was acceleration for 8 seconds. Constant speed for t seconds, so that's 8 plus t. And then it says it decelerates from this velocity to 40. So it's going down to 40 meters per second. Yeah, that's that 40 there. That's that same one there. Yeah, that's that one there, 40. And it's for a further 2 seconds. So if we come back to our graph, we've got 2 seconds for it to accelerate, get down to 40 meters per second. Let's try that again. So it comes down to 40 meters per second there. So that's extra 2 seconds along the time. So that's going to be 10 plus t to reach B. So there's our sketch. Okay, given the distance from A to B is 1404. So reading the question, we get 1404 meters, and we know that the distance is the area under graph. So we can split that into probably 2 trapezium. There are other ways of splitting it up, area 1 and area 2. So area of a trapezium is equal to h over 2 times a plus b. The sum of the parallel sides times half the distance between them. So area 1 is equal to, well, the length of the parallel sides for area 1 are 8 plus t, and the distance across here is t, so it's 8 plus t times t, not times t, plus t, 8 plus t plus an extra t. The height, or the distance between the parallel sides, is 88 over 2. So the 88 coming from there and here on the diagram. That distance there is 88. So we now have 44 times 2t plus 8, which is 88t plus 4 8s are 32, so 320 plus 32 is 352, I think. 320 plus 32 is 352, check. Okay, area 2 is equal to, now this time the heights, if you like, so these bits here are our A and B, So we get heights. The parallel sides are 88 and 40. And the distance between them is here. That's our distance between them, h. So here we've got h as 2 over 2. So that adds up to be 2 over 2 is 1. 40 plus 88 is 128. Okay, let's go back and read the question. The total distance travelled was 1404 metres. Find the value of t. So the total distance equals 1404, which is equal to 88t plus 352 plus 128, which is 88t plus 470 plus 480. Subtract the 480, we get 924 equals 88t. So t equals, that's 880, leaving 44. That's nice, isn't it? So that's 10.5 seconds. Okay, that's the end of that clip. I'm going to do the second two questions on another clip.